Hi again, everybody. Okay, continuing from what we have studied last thing, it was about inequalities, solving linear inequalities when we have got no problem, easily solved with the power of x equal to 1. Then we came to the solving a quadratic, nonlinear inequalities when we have got power of x that is greater than 1. Here, the first example that we had, it was x squared minus 5x plus 6, which is less than or equal to 0. In that example, it's a quadratic equation, and we solved it by factorizing it, putting those factors on the real number line, and then finding test numbers, or choosing test numbers, not finding them, putting in the inequality that we have got, checking for the signs, and the signs decide which part will be our solution. We said since here we have got less than or equal to 0, so we are choosing the part that is a negative number. Now we are coming to example 4. In example 4, it says again, solve the nonlinear inequality that is given to us. The inequality that is given is x multiplied to x minus 1 all squared, and multiplied to x minus 3 all less than 0. In that case, if you look at this, it is not a quadratic inequality. Here we have got 1x here, 2x's here, and 1x here, so we have got x to the power of 4. If we expand that inequality, that expression, we will have x to the power of 4. But it is factorized itself, so you do not need to do the step of factorization. One step has been done further. So what do we need to do? We need to start directly with writing the factors, the numbers that we have got, the numbers that makes this one equal to 0, on the real number line. So we have to sketch the real number line. Let me do it here. Okay. So what's the number that makes that part equal to 0? X equal to 0. Of course, since x has got nothing with it, so 0 makes this expression equal to 0. That expression, when x is equal to 1, this part will equal to 0. And when x is equal to 3, this part will equal to 0. So 0 will make that expression equal to 0, 1 will make that expression equal to 0, and also 3. As we did for the previous one, we are doing the same thing here. We are putting those factors on the real number line. Here we have got 0, then we have got 1, then we have got 3. Here the numbers that we have got divides the interval, the real number line, into 1, 2, 3, 4 parts. Here we had 2 numbers, so we were having 3 parts, but here we have got 3 numbers, so it divides the whole real number line into 4 sub-intervals. One interval is between minus infinity to 0, one interval is between 0 and 1, the other interval is between 1 and 3, the other one is from 3 to infinity. Again, doing the same procedure, we are choosing test numbers, representatives in each interval. A number that is less than 0, we can choose -1, as I told you. You can choose any other number that's less than 0, but we are choosing the easiest one. A representative, a test number between 0 and 1, the easiest one is half, if you want to choose. Okay. A test number between 1 and 3 is 2, you can choose. And a test number between greater than 3, you can choose 4, or any other number that you like. Now we're putting those test numbers one by one into the inequality that we have got. So we will have x instead of x. I will do this once here. Of course, if you can do this one in your mind, or on a piece of paper, on a corner of your paper, it will be totally fine. But every time it's better to do it. It will make the work easier for you. So we will have, instead of x, we will write -1. Okay, -1. If you look at that expression here, this x minus 1 all squared, this one is always positive. Since we have got power 2 here, if you have got power 2, whatever we have got here, whatever we get from here, it is always a positive number. So this one is the x that we have got. Here, without calculating, here is always positive. Okay, that part is always positive since I have got power 2 here. If I put x equal to 2, I will get positive. If I put negative 2, I will get positive number out. So the result of that bracket is always positive. I do not need to calculate it. I do not need to put any number over there. I just need the sign of it, so it is positive. What is remained here? It is remained. We are remained with x minus 3. Instead of x, put minus 1. Okay, and then I have got minus 3 from the inequality. We said we just need the sign. We don't need any other thing. So here I have got minus, I have got positive, and minus 1 minus 3 is also a negative number. So this one is minus. Let's write on it the signs. That one is positive, that one is negative. So negative multiplied to negative, it is positive. With a positive, we get what? We get positive. So we are sure that this part, let me write it with that color. This part is what? This part is positive. So whatever number we are choosing from that side, I will get a positive number. For the second test number, that's half. Okay. Here we have got minus 3. Let me write down these ones. I will make the steps, then do the procedure. The middle part is always positive for all of the terms, so I will just write it as positive. I do not care about the number, what I will get. I just care about the sign. Okay, so here I'm choosing, we have chosen 0.5 and we have to put it in the excess places. So here is 0.5 and here is 0.5. Let's see whether we get positive sign or negative sign. 0.5 is positive. Here I already have got positive sign. And here I have got what? Half minus 3. Half minus 3 is a negative sign. Okay? So positive, positive multiplied to negative, we will get a negative sign. Okay? So any number that we are choosing in that interval, we will get a negative sign. Okay? Now, we are doing that test number 2. If I put instead of that x2, that term is always positive. I don't care if I put 2 or any other number. And instead of that x, I will also put 2. So what do I have? This one is positive. 2 is positive. That part is always positive. Sorry, I wrote it with this. And that part is what? That part, 2 minus 3, is negative. So negative, positive multiplied to positive is positive. Positive multiplied to negative is negative. So that part is what? That part is negative. Now we have tested these 3 numbers, those 3 numbers. What is left? We are left with the last test number, which is 4. I put instead of that x 4. That part is always positive. And instead of that x, again, I put 4. This one again, I have got this one is positive. That one is positive. That one is positive. So positive multiplied to positive multiplied to positive, I get a positive number. So this part, whichever number we are choosing, we get a positive number. Now we want to choose the solution. Which part is the solution? Because we are doing this procedure for finding the solution. We said we are looking at the inequality that we have got. The inequality is less than 0. So that part that I get the solution from must be a number that is less than 0, must be a number that's negative. If you look at that chart that we have got, or let's say that real number line that we have, you see negative numbers here and negative numbers there. So this part will become a solution for that inequality, and also that part. Okay, so those 2 parts will give me the solution for that inequality. What does it mean, a solution? That means if I choose any number in that interval and put it in here, I must definitely get something that is less than 0. So the solution for this one, we do not say from 0 to 3 because 1 is not included, or we can write The solution for this one is from 0 to 3, except which number? Except number 1. Okay, and sorry, this one is an open interval. Why is it an open interval? Because we have got an open interval because this one is not less than, less than or equal to, it's just less than. Okay, so as we said, this interval must be an open interval. Why must it be an open interval? Because here we do not have the equal sign. If we had the equal sign, we would have made it a closed interval. So either we are saying the solution runs from 0 to 3 except 1, or we are saying the solution is from 0 to 1, okay, that part with an open interval, union from 1 to 3. Okay, so that will be the solution for that inequality. That was example 4. We're moving to example 5. Example 5 is a fraction. It's a rational expression. Example 5. What do we have? We have got 1 plus x over 1 minus x, that's greater than or equal to 1. Here you're not starting with the solution directly, since you have got the opposite side of the inequality is 1. We have to make it 0, as you saw from this one and that one. When we have got nonlinear inequalities, we are changing one side of the inequality equal to 0. Here, since we have got 1, first we are moving the 1 to the other side. So we will have 1 plus x, okay, that's the solution, over 1 minus x, minus 1 is greater than or equal to 0. First, we're taking this to the other side. When we take it to the other side, you have studied how to equalize denominator. The denominator of this one is 1. We have to multiply it by 1 minus x. Okay, here this one already has got 1 minus x, so we are just multiplying that expression to 1 minus x by 1 minus x. So that will be 1 plus x over 1 minus x, that expression I have written it as it is, then minus this one multiplied to above, it will be 1 minus x over 1 minus x greater than or equal to 0. Now, since the denominators are the same, so I'm putting them on one denominator and simplify that expression in the numerator. Minus multiplied to 1 will be minus 1, minus multiplied to x will be plus x, okay, and all together greater than or equal to 0. Simplify that expression further. Here we have got 1 minus 1, it will equal to 0, okay, that one together will be 0, and then x plus x will be 2x over 1 minus x greater than or equal to 0. We are doing the same procedure that we did for this one. Now we have got a simplified form of an inequality, so we are doing the same procedure that we did in here. So we have to draw a real number line to check whether it is positive, negative, or whatever we need. Again, what is making numerator equal to 0? Numerator, when x is equal to 0, it will be 0. And when x is equal to 1, that expression will equal to 0. Every time you are checking for those numbers that makes it equal to 0. Then we are putting those two numbers on what? On the real number line. Here is 0. And here is 1. Again, we are choosing test numbers. Okay, we put those two ones on the real number line and we are choosing test numbers. Here we have got 3 intervals. So from that interval, numbers less than 0, I will choose -1. From numbers between 0 and 1, we choose half. Numbers greater than 1, we choose 2. Okay, now we're putting those test numbers into here. If I put -1 into here, what will I get? I will get 2 multiplied to -1, okay, over 1. Okay, so it is 2 multiplied to -1 and 1 minus, instead of x I have got -1. Okay, so that will be what? I again check for only positivity and negativity. It's this sign. 2 multiplied to -1, it is negative, over this one, 1 minus minus 1 is positive. Okay, so negative and positive together becomes what? Negative over positive gives me a negative number. So this part is what? This part is negative. Again, we are doing the same procedure for this one. Okay, this one is one part of it. I'll do the other part here. 2 multiplied to this, 2 multiplied to 0.5, okay, and then 1 minus half. Let's see what do we get. 2 multiplied to a positive number is positive. 1 minus half is a positive number. So here is what? Here is positive. Okay, so that part I'll get a positive number. Now we are left with the last part. Okay, last test number. We have got 2 multiplied to 2, okay, and 1 minus 2. So what do we get here? 2 multiplied to a positive number is positive. 1 minus 2 is a negative number. So positive and negative, I mean positive over negative is a negative number. So what do I get from here? I get a negative number here. So this one, that interval, at any number that I choose, I will get a negative number. From that one, I will get a positive number. And here I get negative number. What is required from us here? It is required from us to have those numbers that are greater than or equal to 0. Greater than or equal to 0 means positive numbers. When we did this one, which part is positive? Of course, that part is positive. So that part will be the solution for the inequality that we have got. How do we write it? We are writing it as 0 to 1. Okay, 0 is included because 0 is from the denominator. Okay, and we have got the equal sign here, so we are filling it up. But 1 is not included. We are leaving it empty. Why? Although we have got equal sign here, but it is in the denominator. If you put 1 here, it makes it undefined. So that's why we are leaving 1 open in here. Okay, so that's all about linear inequalities, quadratic inequalities, and non-linear inequalities in general. We are only, for this section, we are only left with absolute value inequalities. We will be doing this one in class, inshallah.